So the following data are from a random sample of alumni of a small college. Here we have their years they've been out of school, and here we have their contribution in dollar amount to the school. And we want to find the 95% prediction interval for an alumni that's been out of school for 4 years. So this part right here gives you the X value in our prediction interval formula. The 95%, that piece is going to be used to find our T alpha over 2. So we need to go to the T distribution table where our degrees of freedom will be n minus 2. We have 6 pairs here, so that would be 4 degrees of freedom. And then down the 95% column of our T distribution table, and that will give us a T value 2.776. So those are the first steps that we're taking from here. Now the formula itself is quite long, so let's first start with some stuff we'll need. One of the first things you probably should always do, of course, is check to make sure that this is a valid regression, meaning that if we were to do a hypothesis test for the correlation, that's rho equals 0, rho not equal to 0, we're going to want to reject H naught. When you reject H naught, you show that correlation is not equal to 0. That means there is a significant relationship between years and contribution dollars. The easiest way to do that, if you don't want to do it each time with all of the steps, is to use your calculator. There's a built-in test for this in the stat menu. Under the test options, you want the ln-reg t-test. I've already put my data into list 1 and list 2. You can use whatever list you want. You always are doing equal, not equal. So all this stuff just leaves alone. Go down to calculate and hit enter. And there's a couple of ways to do this. I could look at my p-value here. That p-value is less than alpha. I'm using 0.05 because of our 95% in the problem. Usually it is 0.05. Anytime your p-value is less than alpha, you reject H naught. So therefore, there's a significant relationship. The other way is to go down a little bit farther here and look at your R. So your R is equal to negative 0.8829. We could have used our table I with degrees of freedom equal to 4. So I can go right in here and look at this critical value. It says 0.811. So that means if the absolute value of R is greater than that critical value, you reject H naught. So either way of those works. Alright, so we know that there's a significant relationship between these two things. So the next step we want to do is do a 2-bar stat. So again, I've already listed the data in my list 1 and list 2. I'm going to go to the stat button under calc and this time do a 2-bar stats. This is the same function you would do if you wanted to show your work finding A and B in the regression equation, finding the correlation coefficient, all of that stuff. All your sums are listed here. We only need a couple of these for the prediction interval itself. We're going to need the x bar value, we're going to need the sum of the x's, the sum of the x squared, and the sample size. So if I write each one of those values down, I have my x bar equal to 5.3333. I'm going to go out at least 4 decimal places so that rounding isn't too much by the end. The sum of the x's is equal to 32. The sum of x squared is equal to 220. And my n is equal to 6. One other piece of information that we need for our prediction interval is the standard error of estimate. So the standard error of estimate is what your calculator is just calling S underneath the ln-reg t-test. So let me go back to that ln-reg t-test. and it's quite large, 94.2222. That's the standard deviation of the residuals, it's called. So the standard deviation in terms of the units of y in our dollar amount, that's pretty high. So we'll probably get a very wide margin of error when we're done. We also need to know the regression equation. So right when I have this open, here I have my a and my b for this regression equation. We write it as y prime, that's the predicted value of y, equals a, so we put in that number 453.1757, plus bx. So b is a negative number, so I'm going to put that in parentheses just to make sure that you don't forget it's negative. So what we're going to be doing then is, based back on our problem, it was asking for 4 years, so I'm going to plug in x equals 4 in for x in this regression equation, but I'll do that on the next page. That should be everything that we need from here. I do want to just make a quick note, and students were doing this incorrectly quite a bit, is that some of your calculators under the interval menu have one that's called ln reg t interval. That is not the prediction interval. It's completely different, and it's looking at finding a confidence interval around the slope, so we're not going to use that one. Now the prediction interval formula is quite lengthy. And usually what happens is the order of operations gets messed up because there's so many places to put a parenthesis in the wrong spot. It's y prime, that predicted value of y, plus or minus the t value times the standard error estimate times the square root of 1 plus 1 over n plus n times x minus x bar quantity squared divided by n times the sum of x squared minus the sum of the x's, that quantity squared, and those are two different things, so be careful there. Now your book doesn't put in parentheses in here, but this whole bottom piece needs an extra set, and this fraction needs an extra set in here, just to make sure you get it all in there, right? We need to be able to find our value for y hat, y prime. So what we're going to be doing here is taking our regression equation and plugging in x equals 4 to predict the contribution amount for somebody that's been out of school for 4 years. So if I plug that in, I get 251.4189. So that's a dollar amount you would expect on average for 4 years. Now every time we take a new sample, that amount is going to change. So what we're doing is we're finding a margin of error from that $251 so that we can be 95% confident that the average falls within that margin of error. So that's going to go into that. We just listed out our t from our t distribution table. We found the s off the calculator. In sum of x squared, sum of x's, and x bar we found from the 2-bar stats. And this x right in here, that's the x equals 4. So if we start substituting each of those values in, we have 251.4189 plus or minus 2.776 times our standard error of estimate, 94.2222, square root, parenthesis, 1 plus 1, 6, that's the 1 over n, plus, and we have 6 times 4 minus 5.3333 in the parenthesis squared divided by, new parenthesis down here, 6 times 220 minus 32 squared. Since 32 is not a negative number, you can drop this extra set of parentheses. We do need the parenthesis though at the bottom, another parenthesis to end the square root. quite long. There's a lot of places to make a mistake. I plug in this margin of error first. So this is what I'm going to be putting into my calculator. There's no shortcut for this, so just be careful that you have your order of operations correct. So start with your t-score, the 2.776 times 94.222, square root. My calculator, oops, I forgot a 2. Already puts a parenthesis to start the square root out. Then I have 1 plus 1/6 plus 6 parenthesis 4 minus 5.3333 in the parenthesis squared divided by new parenthesis 6 times 220 minus 32 squared. So I end this one, and then I end it again for the whole square root. And then that's my margin of error, 286.8478. And you can do it with the inside pieces and just work your way out. Sometimes that will work just to check your answer. This is going to be, that's not my answer altogether. I have 251.4189 plus or minus that margin of error. So if I take and subtract the two numbers, I get negative 35.4283, and if I add the two numbers, I get 538.2661. So what does that mean? If you are looking at this for somebody that's been out of school for 4 years, you would predict that their contribution amount would be in dollars. Well, we can't have a negative contribution, but up to 538, so we kind of usually truncate that at 0. In all practical purposes, this is just a huge margin of error, so it's very hard to predict what their contribution would be. It's really large because you have such a small sample size. Be careful again with the rounding. You may want to put an example in your page of notes for your test that looks just like this so that you can follow it, putting the parentheses all in the right spots. Make sure that you're pulling S right from the calculator. All these 2-bar stats, pull from the calculator. Don't try to do all of those steps by hand as well.